Welcome back to the Hardware Unboxed News Corner. A few interesting topics to talk to you about this week. Again, still a bit slow in the first few months of the year, especially with the virus-related issues affecting tech companies worldwide. But news always trickles out, especially as we prepare ourselves for a few major launches in the next few months, mostly on the Intel front with Comet Lake. Before that though, I do have a few updates to some of the videos that we've published over the last few weeks. We've had a couple of investigations and pieces generate a bit of discussion, so just wanted to provide some fresh information on both fronts. Firstly, the Tom's Hardware video talking about their VRM testing and their response to our questioning. This video blew up a lot more than we were expecting. Neither Steve or myself really like having to make these sort of drama pieces, but it seems you guys do enjoy them. But we still have no plans to make any more of these videos than the absolute bare minimum, so no chance we'll be turning into a drama channel or anything like that. Anyway, Paul Alcorn from Tom's Hardware, one of their senior editors, did reach out to us privately and apologize to us on behalf of Tom's Hardware for the response we received and discussed in the video. We talked a little bit about this on Twitter, so if you're not following us there, good chance to hop on board. But for those that just want to watch our videos on YouTube, I just wanted to say that Tom's Hardware did reach out to us. They apologized. Paul's a great guy, and there's no bad blood between us and Tom's as a whole. It does sound like Tom's are doing a few things internally to sort out this issue. Don't want to go into all of that because that's on Tom's Hardware to talk about publicly, but one of the things they did mention is they are reviewing their motherboard test methods and will look to implement some of the tests we use for our videos. So that's stuff like using thermocouples on the VRM components and backside of the motherboard rather than using IR measuring devices, and testing with higher power CPUs to stress out the components. It does sound like they're taking our feedback on board and they want to get things right for the future, so we appreciate Tom's reaching out to us and I guess addressing our video in a more proper manner. The other thing we talked about a few times across several of our last videos is the AMD Radeon GPU driver situation, which all started in our video a couple of weeks ago and we've continued to receive lots of feedback on, especially as we keep talking about it in things like Q&A videos. There's not a whole lot we can personally do to fix these issues because we're not employed by AMD on their driver team, and it's really on them to fix the problems. But rest assured that AMD does follow our channel and they do look at the feedback we've been receiving, so the comments and discussion from you guys is being seen by them. Can't say exactly how helpful it will be, but AMD is well aware. On our side though, we have made a couple of polls recently to try and dig a bit further into how widespread their problems are and how many of you have left the red team and purchased a GeForce GPU due to these issues. Now, of course, these polls aren't super scientific or verified to be accurate, but we have been receiving 20 to 30,000 votes per poll, which I think is a reasonable sample size. And for us, we really want to understand how many people are affected with these issues. And we also want to track their progress as they hopefully get fixed in the coming months. So we'll look to revisit this a few more times to see how Navi GPU owners are faring down the track, see how much progress AMD are making, and go from there. We do a lot of GPU recommendations on this channel. We're really invested in fully understanding the issues you guys are facing so that we can make accurate, high quality recommendations. So all the feedback we've received so far has been, super useful on that front. That's all the updates for now. Let's get into some news topics, starting with a range of CPU related stories. While MWC was cancelled this week due to a demonetizable virus, Intel has still gone ahead with plans to launch a portfolio enhancement for their second gen Xeon scalable processors. What does this actually mean without the marketing speak? Well, basically, we're getting new Cascade Lake X server processors, Cascade Lake X being their latest generation of server chips with core counts that range from 4 up to 28 per die. Intel is framing this portfolio enhancement as a big increase to cores, threads, cache, frequency, and therefore performance, with claimed figures of up to 36% more performance and up to 42% more performance per dollar. But realistically, Intel is still limited by their 14nm manufacturing process and an architecture that's a minor variation on Skylake, so they aren't actually achieving a 36% performance gain for their highest end part. Instead, Intel is simply shifting the entire lineup down several price tiers, so the chips you can now get at any given price point have more cores, frequency, and so on. Essentially, this makes the portfolio enhancement a significant price cut to make Cascade Lake X more competitive up against AMD's excellent value Epyc processors. Although in typical Intel fashion, they don't want to call this a price cut, but a performance gain. Different terminologies, basically the same result. There are lots of new SKUs available in this lineup, lineup, most of which use an R suffix to indicate this refresh. But here's an example of how the pricing and performance structure is different. Take the Xeon Gold 6240, which costs $2,445 US and offers 18 cores at a base clock of 2.6 GHz. The new R model, the Xeon Gold 6240R, costs the exact same price, but now offers 24 cores at a 2.4 GHz base. Previously, if you wanted a 24-core processor with similar clocks, you'd need to have spent nearly $4,000 on the Xeon Gold 6252N, or more like $4,700 on a Xeon Platinum 8260. These changes also bring 28 cores to Xeon Gold for the first time, increasing the maximum core count offered with these upper mid-range parts from 24 to 28 cores. Previously, you'd need to spend over $10,000 to get 28 cores at 2.7 GHz in the Xeon Platinum 8280. Well, now that's available in the Xeon Gold 6258R for just $3,950, with the only feature reduction being a cut in supported socket count from 8 down to 2. This is still a lot to pay for these sorts of core counts, but it doesn't look so ridiculous up against Epyc Rome anymore. The 28-core Gold 6258R at $4,000, for example, is more reasonable when AMD sells high-clocked 32-core Epyc Rome chips for about $3,400. $10,000 for this performance on the Intel side was pretty hard to swallow. Or that 24-core I mentioned just before that costs around $2,500. Again, more in line with Epyc pricing, where 24-core chips like the Epyc 7402 are $1,800 or so. Now, Epyc still does hold a price and cost per core advantage across their lineup, particularly for their mid-range and lower core count parts. Without benchmarking, it's hard to say how performance stacks up, but it doesn't seem that Intel are willing to undercut AMD just yet. They're more just interested in being in the ballpark in terms of pricing, while still charging that classic Intel premium and leveraging their brand name. Epyc still holds a number of other advantages, including being built on a more efficient 7nm node, which should offer more performance per watt, which is key for server applications, alongside PCIe 4.0 support and high memory support for up to 4 TB per processor. And clearly these advantages are impacting the market in a big way, or Intel wouldn't feel the need to cut prices so drastically. So yeah, that's competition for you. AMD has detailed exactly how valuable their chiplet design is at a keynote presentation at the 2020 IEEE International Solid State Circuits Conference. 2 key slides reveal the cost savings AMD were able to achieve with the chiplet plus IO die design compared to a theoretical monolithic design of the same core count. AMD estimate that the cost to manufacture a 16-core monolithic processor would have been around 2.2 times that of an equivalent design using chiplets. A lot of this is down to yields on TSMC's 7nm process, which aren't bad or anything, but the larger you make a chip, the more likely a part of that chip will be defective. Splitting the CPU cores into 2 small chiplets and then manufacturing the IO component on an older, cheaper node delivered a significant saving for their 16-core parts, allowing these chips to be priced much more competitively. AMD also showed decent gains for their 8-core part and huge gains for their Epyc design with up to 8 chiplets. AMD estimate that a 16-core monolithic design would have cost 20% more than their final 64-core design with chiplets, while a 32-core monolithic 7nm chip would have been more than twice the price of the chiplet equivalent. Now, I have seen some websites extrapolating these slides to mean AMD's Ryzen and Epyc processors could have been a lot more expensive if they went monolithic, or perhaps there's a huge ability for price cuts here, but these slides don't necessarily mean either. The actual prices for the chips are more determined by market factors and competition than actual manufacturing prices, but no doubt if AMD had gone monolithic, either these chips would be much more expensive and less competitive, or AMD would have sold them at a lower margin. Either way, this design has been a huge reason why Zen 2 has been such a huge step forward for processor performance for both the desktop and server markets. This next story is a simple one. According to Malaysian website Lowyat, AMD are about to begin selling the Ryzen 3 2300X to the general public on March 3rd. In fact, the chip is already available through some retailers in the region, priced at around $70 US when converted. Previously, this chip was only available to OEMs and system builders, not through retailers as a standalone product. The 2300X isn't exactly an amazing chip. It offers just 4 cores and 4 threads, base clock of 3.5 GHz and a boost clock of 4 GHz. Naturally, this is a 12 nanometer part using AMD Zen Plus architecture. It's the lowest end non-APU product in their Ryzen 2000 lineup. There is a reason for AMD to launch this product into the market though. Currently, if you want a 4-core, 4-thread Zen processor, you've got the Ryzen 3 3200G for about $90, and below that we have parts like the dual-core Athlon 3000G for $60. The Ryzen 5 1600AF slots in more at around $100, so offering a 4-core chip with no SMT and no GPU for around that $70 mark, if that's where it ends up, does fit into the existing lineup well, although probably won't be a hot seller given its limited specifications. Now let's blast through the rest of these topics. AMD has launched 2 new low-power embedded APUs in their embedded R1000 series. These aren't overly exciting parts, but we do see Zen being brought down to the lowest power ratings I've seen yet. The R1102G is just a 6-watt part with 2 cores, 2 threads, and a base frequency of 1.2 GHz with a 2.6 GHz boost. The R1305G offers up 4 threads to go with 2 cores and increases clock speed slightly to match its higher 8 to 10 watt TDP. These aren't going to be widely available, but yeah, we might see them in a range of low power mini PCs and other applications. Intel's 10th gen Comet Lake S processors continue to appear everywhere. Intel, really struggling to contain these leaks. We've basically now seen all the processor names, the code names, SKU names, specifications, and even in some cases performance. Nothing here will surprise anyone greatly, but yeah, with all these leaks, we surely aren't far away from Intel making everything official. PCIe 6.0 has hit first draft status, aka version 0.5, and remains on track for a release in 2021. Yep, we've only just started to see PCIe 4.0 adoption in 2019, and 2 years later, we are set to see the final version of the PCIe spec 2 generations into the future. The key spec here is an increased data rate up to 64 gigatransfers per second per lane, a doubling of PCIe 5.0, and quadrupling of what we have right now with PCIe 4.0. While we may be getting PCIe 6.0 in 2021 as a finalized spec, it'll still be several years before we see actual products using the interconnect. PCIe 4.0, for example, was finalized in 2017, and we didn't see adoption until 2019. PCIe 5.0 was finalized last year and likely won't be utilized until 2021. So this monstrously fast PCIe 6.0 revision is still some time away. AOC has announced the Agon AG273QZ, which is their new 27-inch 1440p 240Hz TN display, joining just 2 other panels on the market in the Lenovo Y27GQ and HP Omen X27, which we reviewed here on the channel. We're getting 0.5 millisecond class response times, wide color gamut, a blur-reducing backlight mode, an RGB ring on the rear, and a pointless display HDR400 certification. It should be available before the end of the month at quite a high price tag, around 770 euros, but that is in line with those other 1440p 240Hz displays. And that's it for this episode of News Corner. As always, you can subscribe to get this segment in your inbox every Friday or thereabouts. Do give it a like if you enjoyed it. Leave a comment below if you have anything to say about the news that we've just been talking about. You can, of course, support us on Patreon as well if you are interested. We've recently just put up a vlog video. Apparently, we do vlogs now at Hardware Unboxed. So if you're interested in seeing that behind-the-scenes vlog that Steve made, that's up live now for our Patreon members. Merch also available, links in the description below, and I'll catch you in the next one.